Guys, Paper Pilot here, and back with another video. For a while I haven't uploaded because I was trying to get a new upgrade from it to make videos with. So as you guys can see now I have my tablet, so making videos are so much easier. So today we're gonna be trying paper 5 of Probability and Statistics 1 of AS, May-June 2025, variant 1. So let's just start. The first question we have here is from normal distribution, which is one of my favorite topics actually, because it's actually not that hard. Really, being for real. So the first question is, the masses of the bags of rice made by a company are normally distributed with mean is this mu kg and standard deviation is 0.14. The probability that the mass of a randomly chosen bag of this rice is less than 1.48 is given 0.22. We have to find this. So since this is a normal distribution, we can just write n of mu comma 0.14 squared, because you have to write variance here. Okay, that's just how the rule, even though we don't really need it. So first is p is, that means probability of chosen rice is less than 1.48. This is 0.22. So it's better to always draw a curve. Okay, it's better to always draw a curve. Sigma is 1.48. Sorry, I messed it up a bit. The mu, we don't know mu yet. To find mu, mu is given. This is 0.14, and this is 1.48, less than 1.48. So about here, less than 4. Because if you put it here and if it's less, then it just doesn't match up. So it has to be like this. So to find this part. Now this part is the same as, this whole thing. If you draw this over here again. So we can find this whole thing and subtract it from here. That's how we can find 1.48. We're supposed to find this, but we can also do it the other way of subtracting 1 by 4. Anyways, so how do you actually solve this? So how do we solve this? So first we know this. So pz value is going to be less than 1.48 minus mu by standard deviation. This whole thing, what do we get? Pz less than, we get something. Okay, so whatever the value we get here, okay, .48 minus mu by 1.4, this is going to be equals to 0.22. Now, a lot of people, use MF19 to find the normal distribution from the normal distribution table. But what I like to do instead is use my trusty calculator, which saves time, energy, and in the end, saves our marks. So it's like, if you guys have SAM's FX911EX, then you guys can just, use calculator and just find the inverse of normal of this. So I'm just going to use my calculator. You guys can use the table as well. But in the end, you are gonna get the same value, so it doesn't really matter. So if you find the inverse of this, we get 1.48 minus mu by 1.4. We get the inverse of normal is 0.22. We get negative 0.7721. Multiply this and find mu, which in the end we get 1.588, and 3SF is 1.59. Just the answer. Great, guys. Now, for number 2, find a number of different arrangements of the 8 letters in the word kangaroo, in which the 2 A's are together and the 2 O's are not together. So, kangaroo, right? Kangaroo. There is two O's. There is two A's. What else? That's about it. Okay. So 8 letters, right? So 8 boxes. 2, 3, 4, 5, 6, 7, 8. So in which the two A's are together. So just write two A's over here. They are together. And the two O's are not together. So what I like to do in this type of questions is first I'd like to find the possibility of two A's are together. Always pair them up as one, and then count 1, 1, 2, 3, 4, 5, 6, 7. So 7 ways this can be arranged. 7 factorial into 2 factorial, since this can be arranged, but it doesn't really matter since we divide this by 2 factorial as they're the same alphabet. So that really leaves to just 7 factorial. But we have to divide this by 2 factorial since there's O's rather than. This cancels out, which we get is just 7 factorial by, which we get as the 7 factorial by 2 factorial. Okay. Just see if this works out, guys. 7 factorial. 10 factorial by 2 factorial. 7 factorial by 2 factorial, which we get is 2520. Now we find the possibility when the 2's are not together from subtract from this. So 1, 2, 3, 4, 5, 6, 7, 8. So to find this, basically what I like to do is two A's are together and two O's are also together. Okay. So what do we get? We take both of this as 1. So 1, 2. This is we take them as 1 unit. We take this as 1 unit. 1, 2, 3, 4, 5, 6. So we get 6 factorial. Just 6 factorial. Nothing else really. Okay. So if we subtract this, 2520 minus 6 factorial, that is the answer. So where do I write it actually? Well, I guess we can write it over here. 2520 minus 6 factorial, which is 1800, which is the answer. So basically what I did was first I found the number of arrangements where the two A's are together only. First we take this possibility, then I subtracted that from the possibility that two A's and two O's are together. Okay, so from total minus this, you get this. Simple, right? We can do it another way, but I feel like this is easier for me. Excuse me, guys. Next question is a fair 8-sided dice has faces labeled KANG kangaroo. The dice is rolled repeatedly. Find the probability that fewer than 6 rolls of these dice are required to obtain an A. Fewer than 6 rolls. This is geometric distribution. Less than 6. Okay, less than 6. Whenever it's like this, we find the Q. Probability P is 1 by 8. Wait, A, right. Sorry, it's 2 by 8. It's 2 by 8. 2 by 8. And Q, which is not the probability of this, is going to be 6 by 8. 6 by 8 to the power of 5. 1 minus Q to the power n. It's the formula for geometry. Q to the power r, which we get fewer than 6, right? Fewer than 6. Okay, the answer we get here is minus 6 by 8 to the power. Which we get as 781 by 1024. If you get the answer in a fraction already, so it's better to just keep it in a fraction instead of doing decimal, then you have to write in 3SF. Then it says find the probability that the second A is obtained on the 6th roll of the dice. Okay, so one time A is already rolled, and a second time is rolled on the sixth dice. Okay, so basically 6 times. Okay, 1, 2, 3, 4, 5, 6. He rolls the dice 6 times, and he gets A on the sixth try, but we don't know where he gets the A on the, like, it can be either here or here or here or here or here. We don't know when. Like he gets A. He can be in any one of these 5 plus 5 turns, 5 rolls, right? So he gets one over here, which is 2/8. 2/8 square. He gets 2/8 on 1 into not getting this, which is 6/8, which is 1, 2, 3. It's gonna be 4 since 2 over, yeah, 4 into 5c1, because this one possibility can be anywhere. Okay, this one is fixed, so we don't have to include this. So we get 405. Again, writing in fractions is better. 96. Mark scheme accepts both, but just saying it's better to write in fraction. Oh, and then we have a back-to-back stem and leaf diagram. Okay, so it's better to just label this now. Okay, do want to try this out. Okay, so we have a straight line over here, straight line over here. Then we can write one more line. Okay, so this is going to be, okay, I made it too big, but stem, this is Herones. It says guild on the left hand side, so guild should be here. Okay, nice. So now we just draw it as such. The lowest value of Herones is 7. Then it goes 8. Then it goes 9. Then it goes 10. Okay. So from here to 10.8, right? So Herones is, oh, okay, this 1. Then this 3. Then 5 and then 7. 5 and 7. Then 2, we get 2. Wait, sorry, 2 over here, 2 over here. We also have 2 over here, so we can just do this. We get 9. 9 over that side as well. Okay. 2, 3, 5, 7, 9, and then 9 again. Then 10, we don't have any values over here. Right. And over here too, we have 2, 3, 6, 6, 2, 3, 6, and 6 again. 6 and 6. It has to be in ascending order. You cannot just really put anything. 6, 6, and then what else do we have? We have 8, right? 8. And then 9, we have 2, 7, then 8. Nice. And then over here, we have 0, 4, 0, 4. Easy peasy, lemon squeezy, okay? Now it says find the median and interquartile range of the times. So median, basically, there's a total of what? Total given is 11. So either 5 and 6, right? So for girls, 1, 2, 3, 4, 5, 6. So between this, okay. So the median is going to be, it's between this and this. The median over here is, it's going to be this right here, 8.8. That's exactly the middle, right? Hence it's 8.8. So that's the case. The median is 8 8.8 seconds. Now we have to find IQR. So the formula for IQR is upper quartile minus lower quartile. So we know the median is 8.8, so this will be this. So we have to, sorry, not this 8.8, the other one. So 0.8, right? Okay, so substitute this, and this. So from this part, we have to find the lower quartile. From this part, we have to find the upper quartile, right? Okay, so from the lower quartile, we can see it's 8.3. 8.3. And over here, the is 9.8. This is the lower quartile. This is the upper quartile. Subtract them. We get 9.8 minus 8.3. We get 1.5. 1.5 is the answer, right? Next off, the two other teams of runners, the Eagles and the Swifts, also took part in the event. The recording times in seconds for 20 runners from the Eagles and 30 runners from Swifts are denoted by X and Y. Given that summation of X is this, summation of Y is this. Find the mean. So total mean is summation of both is given, so we just add them together. Oh, actually, this part's not given yet, but we can find it out pretty soon. So summation of Y, there's how many runners? Summation of Y, okay, 30 into the mean is given as 8.4. So summation of Y is 8.4 into 30, which is 252. So this plus 252 divided by 50, which is the total number of runners, and we get ourselves the value. We get 8.54, right? 3SF. Nice. Now it is given that the summation of x squared is this. It is also known as standard deviation of times from all 50 runners is 1.38. Find the value of this correct to one decimal place. Okay, pretty easy actually. So we just have to use the formula, that's it, and make an equation. So 1823.0 plus summation of y squared divided by the total number, which is 50, minus the mean, which we found before, but do not use this value as a rounded off value. We cannot use a rounded off value. So instead of being lazy, we just have to do this again by 50 whole square. Now this whole value is equals to your 1.38. Now you just have to solve this value, and you should get the value of 1918.8 one decimal place. That's why it's like this, right? Okay, now in question number 4. Every Saturday, a particular community holds a puzzle event to raise money for a new leisure center. Competitors attempt to solve a puzzle as quickly as possible. Last Saturday, 600 competitors took part. The times taken to complete the puzzle were normally distributed with mean 32.4 minutes and standard deviation 2.5 minutes. Okay, so normal distribution. How many competitors would you expect times between this after mean times? Okay, normal distribution once again. Nice. 32.4 is the mean. 2.5 square sigma. Okay. So it says 1.2 minutes of the mean time. So, okay, how can this be? Basically, it can be x minus mu 1.2 or it can be minus 1.2, since it's 1.2 mean times, right? Which we can solve further is minus 1.2 by 2.5 x minus mu by sigma equals to 1.2 by 2.5. Like, it's basically what I'm trying to say here is that since there's a curve here, okay, and this is the mean, it can be either from here or here, which is this. These are the values for this, by the way. So we basically have to find the area for this, right? So how can we find the area of that? Well, we know minus 1.2 by 2.5 and 1 by 2 by 2.5. Okay, right. So this is the sigma given standard deviation. Z value we get as 0.48 minus P. Z value we get as 0.4. Sorry, I'm gonna run out of space here. Let's just write it again. Get the value as PZ 0.48 minus PZ 0. Sorry, it's getting a bit annoying. Wait. Minus 0.48. Okay. So if we do that, either using your calculator, using the normal distribution sheet, we get this value. Okay. Minus 1 minus 0.6844, which we get as 461,1250. Now this is the probability, and it says the number, just the number of values. So you have to multiply this, into 600, which gives the final answer of 221.28. But it says how many competitors, so it cannot be a fraction. So the closest value is 221, because that is actually a total number of competitors. That's going to be the answer. Okay. So in this Saturday's event, 60% of the competitors had times less than 36 minutes. 9 competitors who took part of the Saturday's events were random, and probably at least two and fewer than 8 of these competitors had time less than this. So this is basically an approximation question, which basically it has binomial distribution, normal distribution, both together. So less than 36, less than 36, less than 36 is 0.6, which is 60% represents probability, and the binomial given here is 9, that's a total number, and the probability of success is 0.6 again. Okay, so it says at least 2 and fewer than 8, right? So it can be 2 or 3 or 4 or 5 or 6 or 7. Okay, basically within these values. Okay, so how can we do that? It's basically this thing, right? So a simple way of doing this actually, so let me just copy this. Sorry, wait. So let me just copy this real quick. Okay. Okay, I couldn't copy. Wait, P2 greater than or equals to X x greater than less than 8. We can write this as 1 minus probability of 9, 1 minus probability of 0 plus probability of 1 plus probability of 8 plus probability of 9. If we do that, you get the value of 0.96. Or if you cannot, if you don't understand the shortcut way, you can obviously do it the long way by adding this and this and this and this and this and this. But to save time, I subtracted from total, which is of course 1, from probability of 0, since that's not included, probability of 1 because that's not included, probability of 8 and 9 because that's also not included. Alright, so subtract them from total, and to find the thing which is included, this is the answer. Alright, so 80 competitors who took in the Saturday's event are selected at random. This is approximation, because it's given approximation right here. And the probability that more than 50 of these competitors has time less than this. So this is binomial first of all. And we know 80. And less than this is 0.6. So we have to find the new mu and new sigma. Mu is NP. So 80 into 0.6. Right. Which we get as 48. And sigma square, which is variance, is NPQ. Which basically means this 48 that we got here. Multiply that by this 0.4. Just the probability of not getting this, which is 19.2. Now use normal distribution here. 48, 19.2. So probability of y less than 50. Right. How do we find less than 50? This is approximation here. So whenever it says less, you subtract 0.5 from this. That's how I remember it. Well, no, it's greater than here. So sorry, it's greater than here. So you have to add 0.5. So y is greater than 50.5. Now we know all the values. Just do it as normal as possible. 0.5, 48 root over, because this is variance not sigma, 15.2. And using the calculator or the EMF19, you should get 0.284 as the final answer. Yes, as always. Moving on to question number 6. In a group of 20 musicians, there are 9 guitarists, 5 drummers, and 6 musicians. Okay, from these 20 are chosen to perform. Okay, so first of all, this is not permutation, this is combination, because we're selecting. It's selection. Selection can never be permutation, because it doesn't matter which order you select. It doesn't matter if you select a guitarist first, or a pianist first, a drummer, or whatever the hell you guys like. So basically you have to choose 20, but there's also given find the number of different ways in which 6 musicians can be selected if there must be at least 3, at most 2, and exactly 1. So at the very least there has to be 3 guitarists. So for these type of questions, what I like to do is first give guitarists, make rows and columns of this, since that's easier. Guitarist, pianist, and drummers. Okay. Wait, let me just fix this again. Nice. Okay. So there has to be 3 guitarists. So 3, and there can be one possibility to 3, 2, 1. There can be 3 guitarists, 2 pianists and 1 drummer, which adds up to 6. Or there can be 4 guitarists, 1 pianist, and 1 drummer. That also fulfills the requirement. Or there's another third possibility, which is 5 guitarists, 0 pianists, because it never says that. It says at most, that means it can be 0 pianists as well, and exactly 1 drummer. These are the 3 possibilities that you can come up with. So for the first one, we get 9C1 into 9C3 into 6C2 into 5C1, because that's a total. Out of 9 guitarists, you're taking 3. Out of 6 pianists, you're taking 2. And out of 5 drummers, you're taking 1. Or for this, we get 9C4 into 6C1 into 5C1. Or for this, you're gonna take 9C5 into 6C0, since we're taking nothing here, into 5C1. Add them up. That's gonna give you the final answer, which should be 10710. Pretty simple, right? Now, 3 bands will be selected from the original group of 20 musicians. Each band will consist of 3 guitarists, 1 pianist, 1 drummer. Okay? Okay. No musician can be in more than 1 band. So basically, if it's in 1 band, it cannot be more than 1 band. The first band selected will play a concert in France. The second band selected will play in Italy. And the third band selected will play in Spain. Find the number of different ways in which these 3 bands can be selected. Okay, this seems a bit tricky, but okay. First of all, there is total of 9 guitarists, 6 pianists, and 5 drummers, right? Okay, so how can we do this? So each band will consist of 3 guitarists. So there will be 3 guitarists. There will be 1 pianist. There will be 1 drummer. Okay. So there's a few ways you can do this. Okay, so for example, in the first band, you get this. First band, you take out of 9, you take C3, and then out of 6, you take 1. Out of 6, you take 5. So for first band, you basically take this 9C3, okay, 9C3 into 6C1 into 5C1. Or for the second band, you have now out of 9, you have only taken 3. So how much left? There's only 6 guitarists left. That's why out of 6, you take 3 again. Basically, you're separating them into groups and then separating them the leftovers into more groups. Take out of this into 5C1 into 4C1, and for the third group, you're gonna take 3C3, as there's only 3 remaining, into 4C1 into 3C1. Okay, so if you multiply this, you're gonna get over here, you get 2520. Over here you get 400. Over here you get 12. So if you add all these up, that's gonna be your final answer. 2520 plus 400 plus 12, which gives the answer of, oh, you don't have to, sorry guys, it's not plus, because these are and, this is and, these are not options. This is what happens. On the first band you take this is and, so into this, to multiply all of this, you're gonna get it at a very large value, which is actually answer 1209600. This is your final answer. Was this the last question? No, we still have a few more questions. Okay. Oh, this is the last question. All right. So a bag contains 10 marbles, of which 4 are red, 6 are blue. 4 marbles are selected from the bag at random without replacement. The random X notes and blue marbles taken. Okay. So Px equals to 2. So 2 blue marbles are selected. So in total, how many marbles are there? Total, there's 10 marbles. Okay. 4 marbles are selected from the bag at random with a replacement. Number of blue marbles. So out of the 4 marbles, you're gonna get 2 blue marbles. Okay. You're gonna get 2 blue marbles. Okay, interesting. 2 blue marbles. So, oh, you're gonna take 2 blue marbles. So out of 6 blue marbles, you're taking 2. So 6C2. And the rest you have 4, so it has to be red since you're only taking 2. So since probability divided by the total, which is 10C4, because over here the arrangement does matter in a sense, since you don't know which after which, like for example, you don't know if you're gonna take blue first then red, or red first or then blue. That's why you're gonna use combination is easier. So from this you are going to get 3 out of 7. Since out of six blue marbles, you're selecting 2, and then the rest has to be red. Since you're only taking blue, the rest has to be red, divided by the total number, which is out of 10 marbles, you're selecting 4. That's why 10C4. You're gonna get 3 by 7, which is your answer. 2 marks, guys. So think smart. Now, probability distribution table. Okay. Probability distribution table. So how many marbles can you actually choose? You can either not get any blue marbles, so 0, or you can get 1 blue marble, or you can get 2 blue marble. This case is not really adding up. Or you can get 3 blue marbles. Okay, this is not doing that good. Three blue marbles, or you can get 4 blue marbles actually. Okay. So how can we actually do this? Okay, so we already know for probability of 2, we already know, which is probability of 2 we found out is 3 by 7. Okay, 2 blue marbles, 3 by 7, we know this is 3 by 7. Okay, 3 by 7, but 0, that means he doesn't get any blue marbles. So if he doesn't get any blue marbles, all 4 are red. So probability of getting this is basically 4 by 10, this into 4 by 10. Okay, wait, so 4 marbles selected in the bag at random, 10 marbles, 4 are selected. So okay, wait, 6. I think it's better to do this manually actually. So let's think of it like this. Okay, so probability of 0, that means he doesn't get any blue marbles, is out of the 4 red he gets all the 4 red, and for the 6 he gets 0, divided by the total, which is 10c4, which we get as 1 by 210. Okay, so this is going to be 1 by 210. Next one is probability of getting a 1. So out of 6 he gets 1, out of 4 he gets 3, 10c4, which is 4 by 35, and then for px equals to 2, same thing, 6c2, 4c2 divided by 10c4, which we get as 8 by, oh wait, 2 we already found out 2, so we don't have to find this. We can find this though. Hold up. This again. Px equals to 3, 6c3 into 4c1 divided by 10c4, which we get as 8 by 21. And then for px equals to 4, it's just the same thing again. 6c4 into 4c0 into 10c4, which we get is 1 by 14. So just place these four values over here in the table and you are good to go. 4 by 35, then 8 by 21, 1 by 14. Also guys, just to check, add all these values up, should be 1. If it isn't, then that means I did something wrong. Please comment down below. Okay, find the probability that at least 2 of the marbles chosen are blue, given that at least one of the marbles, at least one red marble, at least one blue marble is chosen. So at least 2, so it can be 2 marbles, 3 marbles, or 4 marbles. Okay. So probability of the number of blue marbles being greater than 2, given that red has to be equals to 1 and blue has to be greater than equals to 1. Okay, that's basically what we're dealing here, this thing. So first we have to find the intersection between this. So how can we find the intersection between these? Okay, so blue has to be greater than equals to 2 and red has to be this. So how can we arrange the first? So at least 2 marbles are chosen, at least 1, at least 2. So okay, it can be either 3 blue and 1 red, or it can be, well, it can be 2 red, wait, it can be 2 red and 2 blue. Okay, down, these are the only 2 possibilities for intersection between these two. And given that red is greater than equals to 1, blue is greater than equals to 1, which means it can be 3 blue and 1 red, or it can be, well, it can be 3 red, 1 blue. Is that all? Is that all the possibilities? Let me think. Wait. Greater than equals to 2 equals to 1. No. Oh, right. There can be one more actually, which is 2 red and 2 blue. Okay. This is pretty confusing actually. It's actually taking a long time to tell. So basically it says to find a probability that at least 2 of the marbles chosen are blue. So it can be at least it can be 3 blue marbles. Right. And but it cannot be 4 blue marbles because that means there's no red marbles. But over here it also says that at least 1 red marble. So at most there can be 3 blue marbles, and at least there has to be 2 red marbles. So from that you can find the intersection this and this. Given that at least 1 red marble and at least 1 blue marble are chosen, so divided by, so at least one and at least one and at least one blue, at least one and at least 1 red and 1 blue. That means there can be 3 blue 1 red, or 3 red 1 blue, or 2 red 2 blues. Basically the combination between this is given in here. Okay, so now you have to just multiply the probabilities, which we get 3 reds and 1 blue, which is 8 by 21, using the probability distribution table, which we did above here. 21 into 3 by 7 divided by 8 by 21 plus 3 by 7 plus 4 by 35. The final answer we get after doing all of that is 85 by 97. There you have it. That's the end of the paper. I don't think there's anything more. Yep. Overall, this paper was, I wouldn't say it's really easy, because some questions you have to think about. For example, this question you have to think about it, and this part might be tricky to some people. They might just do it normally and forget about the combination. On this part was also kind of tricky actually, because you have to keep dividing into 3 groups: the first group, second group, and third group. Overall, I would say this paper was mid in difficulty, not too hard and not too easy. So yeah, I think that's gonna cover this video. Oh, if you guys have any queries or any problems, make sure to comment down below. I will be always in touch with you guys. If you guys any queries or any problems, I will comment down below as fast as I can. And if you guys have any specific past paper that you guys want me to solve in maths, physics, anything, so make sure to comment down below. I'll try my best to upload a video as soon as possible regarding the solution of that paper. That's gonna be it. Make sure to like and subscribe and turn on post notifications to watch more videos of this and learn new things, new techniques. That's it. Paper Pilot out.